Good morning to all. Let us start today's lecture. Today I am going to cover the following topics: friction, static, kinetic and rolling friction, friction as a necessary evil, methods of reducing friction, circular motion, bending of a cyclist. So let us start today's lecture. Friction. Now, static friction. Let this is a table. An object is kept over it whose weight W is acting in the downward direction. The reaction on the object is acting in the upward direction. Now, if no force is exerted on the object will not move. But as we apply force F on it, now there will be a force of friction Fs which is acting in the opposite direction, and because of this static friction the object will not start to move. Now if we increase the friction, if we increase the force will overcome this force of friction and the object will start to move. Let us see again. Now initially force F is applied. Because of the force of friction, the object is not moving. As we increase the force, the object starts to move. So this is the condition when it overcomes the force of static friction. The force of gravity W is equal to mg is equal and opposite to the normal reaction force N of the table. If the body is applied a small force F, the body in practice does not move. If the applied force F were the only external force on the body must have moved with acceleration A is equal to F upon m, however small. Clearly, the body remains at rest because some other force come into play in the opposite direction to the applied force F, resulting in zero net force on the body. This force Fs, parallel to the surface of the body in contact with the table, is known as the frictional force or simply friction. The subscript S stands for static friction. Static friction does not exist by itself. It comes into play the moment there is an applied force. As F increases, Fs also increases, remaining equal and opposite to the applied force up to a certain limit, keeping the body at rest. So in nutshell, we can say that the friction comes into play only when some external force is applied over it, or whenever there is a relative motion between the two surfaces in contact, the force of friction comes into play. Since the body is at rest, the friction is called the static friction. Since the body is at rest up to the maximum limit, Fs maximum, it is called the limiting value of the static friction. Static friction opposes the impending motion. The term impending motion means motion that would take place but does not actually take place under the applied force if friction were absent. When the applied force F exceeds the limit Fs maximum, the body begins to move. Laws of limiting friction. Now, Fs maximum is independent of the area of contact. It varies with the normal reaction force F approximately as Fs maximum is directly proportional to N. So, the two important laws, that is Fs maximum is independent of the area of the contact and it is directly proportional to the normal reaction. When we remove the proportionality sign, then proportionality constant comes, which is known as mu s. Mu s is a constant of proportionality depending only on the nature of the surface in contact. So mu s is equal to Fs maximum upon N. Mu s is called the coefficient of static friction. The law of static friction may be written as Fs less than equal to mu s n. That means it is either equal to mu Sn or it is less than mu Sn. Sliding or kinetic friction. If the applied force F exists the limiting limit Fs maximum, the body begins to slide on the surface. When the relative motion has started, the frictional force decreases from the limiting value of the static friction Fs maximum. Frictional force that opposes relative motion between the surfaces in contact is called kinetic or sliding motion. So whenever there is a relative motion between the two surfaces in contact, then the friction is in place of the static friction, it is called the sliding friction or the kinetic friction. It is denoted by Fk, subscript K. Laws of kinetic friction, again, Fk is independent of the area of the contact. It is nearly independent of the velocity. It varies with the normal reaction force approximately as Fk is proportional to n, or Fk is equal to mu kn, where mu k is constant of proportionality depending only on the nature of the surface in contact. Mu k is equal to Fk upon n. Mu k is called coefficient of kinetic friction. Mu k is less than mu s. When relative motion has begun, the acceleration of the body is F minus Fk upon m, because when the body has started motion, then the force acting on the body is F minus Fk. Both are in opposite directions, so F minus Fk upon m gives the acceleration. For a body moving with constant velocity, F is equal to Fk. If the applied force on the body is removed, A is equal to minus Fk upon m, and the body eventually comes to stop. So that means if no force is acting on it, then there will be a retardation, and after some time the body comes to stop. The law of friction do not have the status of fundamental laws like those for gravitational, electric and magnetic forces. They are empirical relations that are only approximately true but yet useful in mechanical applications. Rolling friction. A body like a ring or a sphere rolling without slipping over a horizontal plane will not suffer friction in principle. At every instant, there is just one point of contact between the body and the plane, and this point has no motion relative to the plane. In this ideal situation, kinetic or static friction is zero, and the body should continue to roll with constant velocity. Let us see that if the ball is rolling on it, then it should move with the constant velocity. If a wheel is rolling on a surface, then it should move continuously without stopping. But in actual, it does not so. However, in practice, this does not happen and the body comes to rest eventually. So let us repeat me again that rolling friction, a body like a ring or a sphere rolling without slipping over a horizontal plane will not suffer friction in principle. So if this does happen, then the body does not come to rest and it should move continuously. But in practical, it does not happen so. To keep the body rolling, some applied force is needed. This indicates that there is a rolling friction though it is much smaller by 2 or 3 orders of magnitude than the static or sliding friction. But the rolling friction is there. That is why we need some force to keep the body rolling over any other surface. Just like this is a ball, this is moving, and if so no external force is applied, then it will stop after moving through a distance. Rolling friction has a complex origin. During rolling, the surface in contact gets momentarily deformed a little, and this results in a finite area, not a point, of the body being in contact with the surface. The net effect is that the component of the contact force parallel to the surface opposes the motion. Now, friction is necessary-able. In many situations, friction has a negative role. It opposes relative motion and hence dissipates more power in the form of heat, like in a machine with different moving parts. It causes wear and tear of a machinery parts in contact and the type of automobiles. In many practical situations, however, friction is critically needed. Brakes in machines and automobiles use friction to stop the motion of them. We cannot walk without sufficient friction. It is impossible for a car to move on slippery roads. On an ordinary road, the friction between the tire and the road provides the necessary external force to accelerate the car. So, in this way we can say that friction is a necessary evil, means it is required but also it is a disadvantageous, means in some cases the friction is very necessary, so we have some advantage of friction, but in some cases we also have disadvantages of the friction. Now, methods of reducing friction. Solids, for example graphite, semi-solids, for example grease, liquid, for example oil, lubricants can be used to reduce the friction. So solid, liquid, semi-solid or the liquid, these are the three types of the lubricants which can be used to reduce the friction. Ball bearing can be used to reduce the friction since the rolling friction is less. A thin air cushion can be used between the solid surface to reduce the friction. A proper combination of alloy surfaces can reduce the friction. This is a ball bearing, air cushion, air jet, the lubricants. So in this way we can see that friction can be reduced. Now, circular motion. Bending of a cyclist. While negotiating a curve, a cyclist bends towards the center of the curve to keep a safe balance. You must have experienced yourself also. When you drive a cycle, you lean yourself towards the center of the curve so that you cannot fall down or to keep a balance. Now, this is a circle. O point, center of the circle, R is the radius, cycle is moving on it with velocity V. N is the reaction with the surface and the tire, between the surface and the tire. If we make the components, then theta is the angle from with the normal. So the reaction N will have the two components, N cos theta and sin theta. The weight is equal to mg, which is acting in the downward direction. F is the FCP is the force which is acting towards the center. The angle theta through which the cyclist bends can be calculated as given below. The weight of the cyclist plus the cycle acts in the vertically downward direction. The normal reaction N acts in the direction as shown in the figure due to bending through the angle theta. The centripetal force FCP is equal to mv square upon r acts towards the center of the curve. The normal reaction N is resolved into two components, N cos theta and sin theta as shown in the figure. N cos theta and mg are equal and opposite, so balances each other. N sin theta provides the necessary centripetal force mv square upon r to the cyclist. So we can say N cos theta is equal to mg, N sin theta is equal to mv square upon r. If we divide these two equations, then we will get tan theta is equal to v square upon rg, or theta is equal to tan inverse v square upon rg. The cyclist will bend through an angle theta from the vertical. In reality, theta will be little less owing to the friction available on the road. So that is all. Thank you and have a nice day.